Let's think what we can achieve with a good caching strategy and what are the possible negative implications. Caching strategy can make a website available offline. It can make it possible to render something immediately, and it can prevent some unnecessary downloads. But if you try to get all these benefits at once, you will introduce some problems even with the smartest caching strategy. For instance, trying to display something immediately often means that application updates won't be visible to a user as quickly as it happens in a normal application. Next, some caching strategies may produce a slightly distracting user experience. It may happen, let's say, when the fresh content is a bit late and you try to display it on top of the older content. Next, when you try to design a really clever caching strategy, it quickly gets very difficult to reason about. Of course, any development task requires mental effort and takes time. But when you build a service worker, you're especially vulnerable to over-engineering, because the complexity is often very high and the gains are often quite miserable. In practice, we can't get all the good stuff and avoid all the bad stuff. Ideally, you should come up with some trade-offs depending on the needs of your product. An ideal solution will most likely combine different caching methods. For each type of resources, you should consider how frequently it updates, how critical is this resource, and many other things. A really good caching strategy will be very product-specific. So ideally, you should go to offline-cookbook and pick the right strategies depending on your goals. And I can't precisely tell how to choose the right strategy for a given product. Now I'd like to find a simple generic solution that will provide at least basic offline support. I mean, I'd like to make the user experience at least slightly better and with minimal trade-offs. And I hope this small research will help you understand how different caching strategies behave in different situations. So here is the goal. Make a static part of an application available offline without breaking anything else and without too much engineering. The instantaneous rendering will be optional for now. Again, I think that showing something immediately is a much greater enhancement than offline support, but it's harder to achieve without substantial trade-offs. We will most likely sacrifice the freshness of the content, and it will quickly get really complex. And let's try to serve only perfectly fresh content. Because the basic offline support is a very subtle improvement, so we can't afford any damage to other sides of an application. And let's clarify what means the aesthetic part of an application. There is a more popular and cool sounding term for that, application shell. It's actually quite a sophisticated subject. For my example website, app shell doesn't make much sense. Basically, this entire site is a shell. The better example is Twitter. From my understanding, this sidebar is a shell, because it remains untouched when we navigate between the roots of this single-page application. Let's compare different caching strategies using this table. It describes what will happen over time when we open a website while being online, then offline, and then we update our application, and then again open it online, and online again. And let's ask some questions on every step. Would the content be available without connection? Would it be rendered instantaneously? And would it be the most recent content? By default, without any caching strategy, a user will first see version 1, then a dinosaur in offline, then a version 2 in online, and then a dinosaur in offline. That's pretty obvious. Now let's look at the naive caching strategy from my example website. It tries to serve the application's shell from cache only, and it just fetches everything else as usual. In offline-cookbook, this approach is called cache falling back to network. On the first online visit, it will show version 1, and it will cache version 1 on service worker installation. Then it will show version 1 offline. Then after an update it will still show version 1, and it may cache version 2 if the service worker file was updated and reinstalled. On the next visits it will show version 1 or version 2 depending on whether the service worker file was updated. An app shell will be displayed immediately starting with the second page load. Again, the problem here is that we have a stale content at least once after the app was updated, or we have a stale content forever if there was no change to a service worker file. Let's modify the strategy a little bit and try to fix this problem. First, let's fetch anyway and update the cache every time. The fetch call will come before the return statement, and we will use the fetched response if cached response wasn't found. And when we receive a fresh response, let's update the cache. Basically, this strategy is almost identical to the original naive method, but there is one important change. We try to update the cache on every request, so that the updated content becomes available on the next fetch, perhaps on the next page load. The code quickly gets messy and unreadable, but it's hard to avoid that, because there is always a ton of asynchronous stuff in service workers. I tried to rewrite this to async await, but it wasn't any better. Anyway, I think the syntax must be pretty obvious. Perhaps this clone command may be a bit confusing, but I suggest that you Google it yourself. Offline-cookbook calls this strategy Stale-while-revalidate. The code is slightly different, but it does the same thing, and with the same degree of ugliness. So what will happen to the app shell with this strategy? First, version 1 will be displayed, and version 1 will be cached on service worker installation. Then version 1 will be displayed offline. After an app update, a user will still see version 1 on the next visit. Meanwhile, version 2 will be cached either on fetch or on service worker installation. Then version 2 will be displayed offline, and the same online. This strategy ensures that, beginning with the second visit, the app shell will be displayed immediately. So Stale-while-revalidate brings offline and immediately displayed content. But it still introduces a stale content for at least one page load since the app update. So it's not perfect for the app shell. As offline-cookbook suggests, Stale-while-revalidate is suitable for resources where having the very latest version is non-essential, for example avatars. Here I'd like to make a remark about serving the fresh content. Even if your service worker is designed to fetch a fresh file from the network, it doesn't necessarily mean that it will fetch it. That's because any request may be intercepted and blocked by the browser cache or HTTP cache. So anyway, you need to think about setting the right HTTP headers if you want to be sure that stale content has gone.